2009, Form B, Problem 4, says the graph of the polar curve, r equals 1 minus 2 cosine theta for theta values from 0 to pi is shown above, I think it means to the side. Let S be a shaded region in the third quadrant bounded by the curve and the x-axis. For part A, we're supposed to write the integral expression for the area of S. For this one, the hardest part would probably be choosing the bounds. I personally just plugged 0 in for theta to get started. So like cosine of 0 is 1. So you'd have 1 minus 2. So your r value would be -1. So you're facing 0, but then you went back 1. So this point right here came from a theta value of 0. And then to find this point where this angle that would make the region kind of close out, I noticed the r value is 0, so I just solved algebraically, setting r equal to 0. So for part A, if you solve this, you're basically just looking for when cosine theta would be 1/2, and so your angle would be pi over 3. I hope that makes sense. So this angle is at theta equaling pi over 3. So there you go. Anyway, so you want to set up an integral that would add up infinitely many infinitely thin sectors that would start at 0 and stop at pi over 3, creating that region right there. So your area then could be found by doing 1/2 integral from 0 to pi over 3. R is 1 minus 2 cosine theta squared d theta. There we go. Okay. Let's see, scoring for this part. They're going to give 1 point for the limits and the constant. So from 0 to pi over 3 and the 1/2. Now the 1/2 could also be inside your integral, but most of us probably put it here. And then they're going to give you 1 point for the integrand. So for the rest, essentially. There you go. Okay. Now part B is the meatiest part of this particular problem. Find dx d theta and dy d theta. So the first thing you need to do is get, the plan is to take the derivative with respect to theta of x. So that means that you need x in terms of theta. So first start with your conversion between rectangular and polar. X is equal to r cosine theta. And then you want this all in terms of theta for your d theta purposes. So we're going to replace r with its definition for this problem in terms of theta. So x is equal to the quantity 1 minus 2 cosine theta, but then times cosine theta. There you go. And then up to you, you could leave it like this and do the derivative with product rule, or you could distribute first. I'm going to distribute first. Like that. And then dx d theta would be the opposite of sine theta. Minus 4 times cosine theta, but then times the derivative of cosine, which would be negative sine. So I'm just going to put sine theta here and then make that be positive. There you go. Anything equivalent to this would be acceptable. So here's an example of another perfectly good answer. Since 2 cosine theta sine theta is equal to sine of 2 theta, this expression right here could be replaced with 2 sine 2 theta. Not that you had to, just that you could have, okay? So these are both considered correct answers for that, okay? You want to look out for that swap because sometimes that will be really advantageous. Like if they had asked you to do the second derivative, for example, then that may have been a really good idea to use that swap. Okay. Now let's go for y. So y is equal to r times sine theta, and then replacing r with 1 minus 2 cosine theta. Okay, and you can see a little opportunity here to swap, to use a double angle swap here as well, which I personally prefer to before I take the derivative. So you don't have to. I'll show you the answer you would have gotten had you used product rule up here for the derivative as well. So now for dy d theta, derivative sine is cosine. And then you'd end up with 2 cosine 2 theta if you use chain rule on that part. So here's one version of dy d theta, and then the other version, if I take my answer and replace cosine 2 theta with cosine squared minus sine squared and distribute the negative 2 in, then you have another expected answer. There's a couple different versions because you could do, of course, some fun Pythagorean swaps and stuff on that, but these are the most expected versions. Okay, so you get 1 point for using, even if you screwed things up afterward, you get 1 point for using these identities right here. And then, let's see, the next thing, 1 point. Oh, weird. Okay, they did this a totally different way than we did, but whatever. Okay, basically 3 points. Okay, 1 point. Shoot, this is weird. 1 point for one of these answers. Sorry, the scoring guidelines don't really match our method, but whatever. Okay, 1 point for this answer. 1 point for this answer. And then it says 1 point for dr d theta, but we didn't really do it that way. So I guess 1 point for being alive. So we'll just give you that point. Anyway, let me show you. You can see their solution. They did not get things in terms of theta first. So they, did dd theta on both sides and then used implicit differentiation and then replaced. Oh, no, I guess we could give ourselves 1 point. It says 1 point for dr d theta. So 1 point for the 2 sine theta piece in our work. I don't know. Honestly, it doesn't translate super well. We would have gotten that point, though, just for our method. Okay. All right. Part C. Write an equation in terms of x and y for the line tangent to the graph of the polar curve at the point where theta equals pi over 2. Well, if I was to plug pi over 2 in up here, just to figure out where on this it would be, you could put cosine of pi over 2 is 0, and so you'd end up with 1. So this point right here corresponds to theta equaling pi over 2, and you can see that that's the point 0, 1. If this is an xy plane, then it's at the point 0, 1. So really all we'd have to do to finish this problem out would be to find the slope of the tangent line in terms of x and y. And so basically what we need is dy dx. And so we can use the parametric form of the derivative to get it. So since we have these guys right here. So let's figure out what would dy d theta be when theta is pi over 2, for example. So you can just plug pi over 2 into either of these expressions. I really like this one, so unless I'm going to screw up basic math like I did in my last version of this video. So 2 times pi over 2 is pi. Cosine of pi is -1 times -2 is +2, but then this would be 0 if you're plugging in pi over 2. Yes, so we got +2. I think that's what I screwed up on last time. Okay, dx d theta when theta equals pi over 2. You could plug pi over 2 into either version. I kind of like this one. So 2 times pi over 2 is pi. Sine of pi is 0, so that whole thing's gone. And then sine of pi over 2 is 1, but then you're negating it, so -1. There we go. Okay, so we wanted to know what dy dx is when theta is pi over 2. Well, it would be dy d theta divided by dx d theta. There we go. So we know that the slope of that line is -2, and it's kind of believable with the picture, so that's always nice. So the equation, you could go y equals mx plus b, or point slope. Point slope would be y minus 1 equals -2 times the quantity x minus 0. You, of course, could have any other version of that expression if you want. You can see in the scoring guidelines, they wrote y equals 1 minus 2x. Okay, so points for part C. 1 point for the values for x and y. 1 point for your expression for dy dx. And then 1 point for your tangent line equation. There we go. All right, my friends, that's your 9 points. Hopefully you got a couple of them.